Janakiram, welcome. Welcome to the program.
My pleasure, Jim. I watched some of your videos and I feel honored to be a part of this. Thanks for having me.
Well, it's really great to meet you here. We're meeting here for the first time. I also have seen some of your stuff. It's really, really interesting. You're in Hyderabad, India, which is one of my more favorite places. I used to travel there a lot when we were allowed out of the kitchen. And so I'm looking forward to maybe future trips to India. So hopefully we'll meet live, actually, for the first time as well.
Absolutely.
So the you were involved with Oracle Developer Day India a couple of months ago, earlier in the fall, and you were the keynote speaker at that event. And essentially is a whole day of events, a lot of cloud, MySQL, database. There were sessions on machine learning. It was basically a lot of cloud content. And your keynote was all about cloud native, and you gave a really great presentation about the whole stack, all the different technologies. So maybe we could start off here by just sort of giving us a quick summary of that keynote, and then we'll bridge into some of the newer things that are going on.
Sure. So the theme of my presentation or the keynote at the Oracle Developer Days was Kubernetes as a service. How do enterprises build an end-to-end cloud-native stack that's powered by Kubernetes and rest of the technologies? So what I get excited about is this whole new wave that is becoming a parallel universe. So the universe that I come from and that you come from has traditionally been, physical servers and then the operating system. And on top of that, we had the Java virtual machine and then the application server and a set of components running the front end, back end, and the middle tier, and then the browsers. So that's the traditional world that we have been interacting with. But now, what's most exciting is with this new wave of containers, microservices, and Kubernetes, there is a brand new stack that's being developed and positioned to enterprises. So for those who come from the distributed environment of J2E application servers and rest of the world, it's not very new, but the taxonomy and the terminology is overwhelming, and it is slightly different. So my objective for that keynote was dissecting the enterprise container orchestration stack and calling out every layer of that. Starting from the fundamental building blocks like the compute storage network and going all the way up to the developer experience layer, which is the interface for the developers and the operators.
Interesting. Okay, cool. And one of the things I noticed that you did, and hopefully we can touch on here as well, you talked in detail about really everything in the stack, but you were talking about a lot of, say, industry or vendor solutions, but also open source solutions as well. And I think for developers, we always like to talk about open source and community contributions and things like that. So that was really good that you did that. Okay, so that was the conversation then. Now you're an industry analyst, so you're always looking out for trends and how things are moving throughout different developer communities. What are you working on now? What's the latest in your world?
I'm actually very intrigued by a new trend called WASM. WASM is the WebAssembly runtime. And this is going to take the world by storm. It's the next big wave. It's going to change the way the cloud native universe functions. It's going to fundamentally change the way software is written, packaged, and deployed. So WASM is basically a brand new way of writing code and deploying it. It's a portable, you would have heard this earlier, write once, run anywhere kind of a layer. And it's interesting, we are going back and forth with this. So the latest promise of write once, run anywhere is now delivered by this new technology called WebAssembly. WebAssembly in itself is not very new. It's been around for a while. And like JavaScript and like Java applets that I have experienced 2 decades ago, it all started in the browser. And now, guess what? It is making it to the cloud. It is making it to Kubernetes. And this is the new mechanism of running highly secure, isolated piece of code orchestrated by Kubernetes. So technically, WebAssembly will replace container runtimes like Docker and Containerd, and it will live in its own world. But these packages that the software developers typically write in Rust or Golang or any of these languages, compile it for WebAssembly, deploy it on a Kubernetes node, that's going to be orchestrated by the Kubernetes control plane. And this is going to really bring a lot of new capabilities, particularly when you visualize Kubernetes running at the edge, even Kubernetes in the cloud on bare metal, and even new form factors like IoT devices, because WASM is like a virtual machine. And the code that you write and run on top of that is a very portable, very efficient, very compact set of instructions. So I think going forward, we are going to see a lot of WebAssembly related technologies coming to Kubernetes and becoming a parallel to containers. It's not a replacement. In fact, containers and WebAssembly would work very well together. But my guess is over a period of time, this will become a parallel to the container runtimes and containerization.
Now, do you see this already emerging, or is just something that analysts feel is going to happen? In other words, have the seeds already started?
Absolutely. It is already in place. You know, for example, Microsoft has written something called Crustlet. So Crustlet is a kubelet written in Rust and compiled into a WebAssembly interface. So to understand this, we have to step back a little and visualize how Kubernetes functions. So basically, in Kubernetes, like any distributed environment, there is a control plane and there is a data plane. Data plane is running on a set of worker nodes. And when you position a container, when you submit a container as a pod to Kubernetes, the control plane will take your container packaged as a pod and positions that and schedules that in one of the nodes. Then the node will invoke the underlying container runtime, which could be Containerd or any other standardized interface to manage the life cycle of the container. Now, Crustlet is going to be running on every node. And instead of orchestrating the life cycle of an individual container, it is going to orchestrate a WebAssembly. So you can already see how this is becoming a parallel. So there is a worker node, there is a kubelet, and there is Containerd in the traditional Kubernetes environment. Going forward, we're going to see a worker node, the Crustlet, and then the WASM runtime working together in orchestrating the WebAssemblies that are packaged and deployed. It's already a part of the Cloud Native Computing Foundation auspicious, in the sense it's already submitted and there is a lot of traction, but it is still very new because Kubernetes in itself is very new in a lot of enterprises, but this trend is just emerging. But this is not completely new. It is built on a very proven foundation of WebAssembly that's been around for multiple years. So it's only going to accelerate going forward.
Okay, cool. And you mentioned some other trends as well.
Right. The second trend that I'm actually seeing, which will become more prominent and visible going forward, is the mainstream usage of operators. So again, this is not very new. Kubernetes operators have been around for a long time, but they have been confined to very niche set of workloads and very niche set of applications. But as we move traditional workloads to cloud native universe, and particularly Kubernetes, we need to have additional infrastructure around them. I'll give you a classic example, that resonates with the Oracle audience. Now, if you take MySQL, or for that matter, any database or a stateful workload, there is more to it than just running it. Starting an instance of MySQL is very straightforward. But as you move from day 0 to day 1 to day 2, you need to do a lot of other things to keep the database server up and running. For example, how do you make the database instance more resilient? How do you make it highly available? How do you perform backup and restore? And how do you do a fire drill of that? And how do you configure disaster recovery? And how do you how do you ensure there is business continuity? Now, all these are the questions that the database administrators are responsible for, and they have answers for. They have mastered the art of running databases that meets all these attributes and criterion for a long period. Now, the biggest challenge is when you bring a database to Kubernetes world, it's easy to get started, but very hard to sustain it and maintain it and manage it. Because literally wrapping a stateful workload like MySQL inside a container and then running it on Kubernetes is very simple, straightforward. But when it comes to day-to operations, everything from resilience to business continuity, there is no framework. And that's one of the biggest obstacles for DBAs and even enterprises bringing their traditional stateful workloads and data-driven workloads to Kubernetes. Now, what operators do is they bring in the guardrails to the stateful workload. So they literally enable developers to automate the operations that the administrators or DBAs would do on day 1, day 2, day 3, and throughout the production lifecycle. So now, literally, every database and every stateful workload that is coming to Kubernetes has an operator around it. So the operator automates and brings some of the day-to operations that are manually performed in a very efficient form to the Kubernetes world. So technically, it is running the database plus running the operations around it, and that is what is called as an operator.
So this has been an obstacle for a while, it sounds, right?
Absolutely. Yeah. But now it has become mainstream. To call out some implementations, the data stacks, which is a very well-known Cassandra company. They offer Cassandra in a commercial form with professional services. So they built an operator to run Cassandra at scale in the Kubernetes context. And Oracle has invested in a MySQL operator that makes it easy for DBAs to run MySQL in a cloud-native environment. Then there are some born in Kubernetes databases. For example, PlanetScale DB, which is actually a commercial implementation of an open source project called Vitus. So Vitus brings in the sharding and the distributed capabilities to MySQL, and that is being used by YouTube and a lot of hyperscalers. And that database is now available. And the power behind that is not just the database architecture, but the operator that is enabling all these operations and all these attributes of a traditional database. So we will see more and more operators assisting the migration and manageability of stateful workloads in Kubernetes.
Interesting. Okay. Well, so it sounds like it's going to allow much more productivity. I mean, if it's solving some major blocking problem for a while. What about complexity and security and things like this? Any trends in terms of making things less complex and more secure?
Yeah. So just concluding the conversation around operators. So operators will give you many capabilities, that you would perform manually, including securing your workload, reducing the footprint, reducing the blast radius of your stateful workload, and all of that. But to extend your question to the general security realm and the security context, now that Kubernetes has become boring. Now, when I say boring, what I mean is enterprises have started to accept, appreciate, and adopt Kubernetes. Right. And anything that gets adopted by enterprises becomes boring because it would hit that threshold where the acceptance level has reached its maximum potential. And it is now entering this stabilization phase. And Kubernetes is certainly becoming boring. And that's a good sign. That's a good thing. So with that, the focus is shifting to more of security. And we are actually hearing a lot of emphasis on what is called as zero trust security. And this is becoming more and more important because in the world of internet, and particularly the blockchain, cryptocurrency, and the metaverse and all of that, where the lines between offline and online are getting blurred, it is absolutely important to be secure. So till now, a lot of infrastructure technologies are designed to be open to close. For example, even in Kubernetes, when you set up a brand new cluster and when you get access to that, by default, you are a cluster administrator and you can do anything and everything with it. That is just one example of open to be closed. It starts with a blank slate. It starts with all the doors being open, and then someone will have to manually close every window, every door that's open, and then selectively permit individuals and applications to access. Now that is changing very quickly. We are moving towards close to open, where by default everything is closed. By default, nothing is assumed to be accessible, and then you selectively start providing access to individuals, applications, and third parties. So that is zero trust. Now, basically, you don't trust anyone.
Right. So drawing the distinction from open to closed, which paradigm is safer? Which paradigm requires more work up front in terms of planning, administration, things like that?
Definitely close to open. In close to open, the onus and the responsibility lies with the administrators and the operational teams. So they have to make sure that the entire infrastructure and all the layers that are contributing to your infrastructure are completely secure and hardened. For example, if even before you set up your Kubernetes cluster, you have to secure your nodes that are running Linux operating system. So there are technologies like AppArmor and eBPF that are gaining a lot of traction. So you have to make sure that you are protecting the operating system and hardening the operating system even before you deploy Kubernetes. So it's a shared responsibility between infrastructure professionals, those are running the operational stuff, and also the application developers who are deploying applications on top of it. For example, it's a very common practice in the Docker and container-centric world to assume that your container is running in the context of root. So you assume you have access to everything. But if the administrator blocks any container that runs in the context of root, your container will not even run on it. So you as a developer need to understand, appreciate this whole zero trust security and start making sure that your container runs in that constrained and highly controlled environment. So I call this as a shared responsibility of developers and administrators, where they work hand in glove to secure the entire stack.
So when a developer is approached, or actually even an administrator, so although I'm struggling to sort of, frame this in my own mind because I don't actually work in these systems, for a developer or an administrator, is this a relatively easy change for them to make? Or do they have to really sort of rethink things?
It is not easy. It is not an easy transition. The workflow is going to be
I don't feel so bad then. Okay, so I don't feel so bad then actually struggling my way through it. So
this is not the norm. This is not how a typical workflow executes. This is a fundamental shift in the mindset, and it is not going to be easy because we have to convince the stakeholders, we have to convince the operations teams, we have to convince developers to realize the full-fledged benefits of zero trust security. But that is becoming absolutely critical and almost like a mandatory requirement for all the future deployments.
Okay, cool. Interesting. All righty. So any more trends on your side?
Yes, I want to call out two more just to round off. We're talking about 5 trends here. So we touched upon 3 so far. I talked about the WebAssembly becoming a parallel runtime. I talked about operators enabling more and more stateful workloads. Then I talked about zero trust security and the shared responsibility. And the 4th trend that I want to call out is the multi-cluster management and how GitOps is going to be the front and center of this multi-cluster world. So let me set the context. Again, this is nothing new. We'd only see more and more mature ways of doing it. So, back in the days of VMware and virtualization becoming more and more accessible, everyone ended up spinning up a new virtual machine. I use VirtualBox from Oracle, and I run half a dozen VMs on my powerful Mac, of course, an Intel Mac. And I have a bunch of VMs running in EC2, in GCE, and Azure, and Oracle Cloud Infrastructure. I have no count on how many of them are in stop mode, how many of them are running, and what my bill is going to be. Right now, imagine if that's the case with an individual, what the enterprises have gone through. So they dealt with this thing called the VM sprawl, where they couldn't control how the virtual machines were deployed, provisioned, and run. And they were all over. They were lurking around in data centers, in developer laptops, in public clouds, in private data centers. It was a mess. Now, a decade later, guess what? We are experiencing something very similar, and that is called the cluster sprawl in the Kubernetes environment. So,
I think sprawl is just human. It starts and then it sprawls, right? I mean, it's everywhere.
Absolutely. And it's also an indication that something has become more easier, common, and accessible.
Right.
So today, when you look at Kubernetes, developers are running it inside a mini queue in their laptop. They are running it in their data center, running on top of vSphere. There are managed Kubernetes clusters running in every public cloud. And enterprises have no way to enforce policies, control, and gain visibility into their inventory and where these clusters are running. So this is a real problem, and there is no easy solution to it. But one thing that's going to simplify this is GitOps. So GitOps is going to be the method to the madness. The madness is cluster sprawl. The method is GitOps. So what exactly is GitOps, and why this is going to be the solution for a lot of enterprise IT folks? Well, today, Git has become the most proven, accepted, acknowledged single source of truth. Everything is living in a Git repo, whether it is a GitHub or a GitLab or Bitbucket, but it is available in some well-known location. Now, the policies that the enterprise IT wants to enforce is also going to be stored declaratively in the same centralized repositories. And they'll enforce this rule saying, hey, every time you launch a cluster, the only way you can deploy your infrastructure and applications is by pulling the artifacts out of this Git repo. And guess what? That Git repo is going to have all the policies, all the compliance, and the entire governance declared in a very declarative form in this Git repo that will flow into every cluster. Now, that is the mechanism through which the enterprise IT would be able to at least gain access and visibility into where the clusters are running. So GitOps will become the front and center of multi-cluster management, and it is going to enable enterprise IT to get better control over the cluster sprawl.
So again, like when I asked a little bit earlier, is this already emerging, or is it sort of speculative, for the future?
No, it is not speculative. This is happening today, but this is being used in the CD workflows. So currently, GitOps is already in production. A lot of companies are embracing GitOps, but it is essentially becoming the vehicle for continuous delivery. But that is going to be elevated to multi-cluster management and policy enforcement in 2022 and beyond.
Okay, cool. And presumably just working in the Git environment, this should be, in terms of, GitOps, this just should be relatively seamless for developers because they've already experienced working within this whole framework anyway for many, many years now.
Absolutely. So this is the best of both worlds. So on one side, we are going to use the Git workflow that is kind of proven and extremely familiar. For example, you know how to perform a pull request, you know how to merge branches, you know how to handle these conflicts. So that is already in place. Now, on the other side, you have this new way of doing cloud native operations. So when you bring the familiar Git workflow to cloud native operations, what you have is GitOps.
I see. Okay. Excellent. Okay. Now you mentioned developer experience. That's I think the final trend, but I also have some other questions about that. So what's
Sure.
the trend here with developer experience?
Okay. Honestly, I might sound a bit controversial here, but the whole developer experience in Kubernetes is broken. It's completely broken.
Okay. So
And
why is that controversial?
it is controversial because not many people would want to talk about it. Not many want to acknowledge it. But the reality is, the whole developer story of Kubernetes is completely in a mess and it's completely broken.
Okay, so I was actually looking at your website a couple of days ago, and one of the things that you had there is something about being opinionated, right? So this would fall into that category.
Absolutely. So that's one of the advantages of being an independent analyst. And I'm highly opinionated when it comes to the Kubernetes developer experience. I've been very vocal about it, and I want to emphasize it again. So today, Kubernetes is the new operating system, right? A lot of companies and individuals call Kubernetes as the new Linux. And that's absolutely a great statement, because the role of an operating system is significantly different and even marginal in the world of containers and Kubernetes. You need the operating system only to bring up a container runtime like containerd. After that, you have very little to look up to the operating system. So Kubernetes becoming the new Linux, the new operating system, absolutely. But the success of any operating system lies in the shell, the choice of shells that are available for the end users to explore. For example, imagine dealing with Linux on desktop without KDE and without GNOME. Would the end users appreciate it? No. Right? Now, imagine dealing with a Linux kernel without Bash. It's very hard.
Right.
Now, if Kubernetes is the new kernel, we need a shell, and that's totally missing. If you look at the entire stack, and in fact, you can go back and revisit my presentation in this context. What is glaringly visible, Jim, is I called out choices for open source and commercial for each of these layers.
Right.
But when it comes to developer experience, there is almost none that I can call out.
On either side?
On either side. No, on the commercial side, there are a few. For example, I give it to Red Hat. Red Hat has built a very usable developer platform on top of OpenShift. But on the open source side, there is no portable application layer. Now, let me qualify this statement. What do I mean by an application layer? If I'm a developer, and if I've been transitioning from these waves of using Java source code to jar file, hot deployment of jar files, all the way to the new container world, one thing that I expect, and that is the developer DNA, is here is my source code, give me back a URL, an endpoint. Now, that's been the traditional workflow for ages. You deploy a WAR file, you get back a URL, in an Apache Tomcat or JBoss or any app server. And in the second, I don't know which generation, in the nth generation or n-1 generation that we dealt with, it was Heroku, Engine Yard. Those platform as a service layers gave us the same opportunity, like Cloud Foundry. You commit the code, you do a git push, you get back a URL. And I don't worry about the nuts and bolts of how my stateless services are talking to stateful services, how are they scaled. I don't care. I'm a developer. I write compact, secure code. I deploy. I expect an endpoint. Now, fast forward to Kubernetes. Now, what do I need to know as a developer? Well, I need to know everything that an ops guy knows about Kubernetes. I need to know what is a container, what is a pod, what is a service, what is a config map, what is a secret, what is a load balancer, what is an ingress. And mind you, this is to deploy a hello world application. I'm not talking about running SAP on Kubernetes. I'm talking about running the minimalistic web application on Kubernetes, I need to know a dozen things that I don't care about. So that layer, which is empowering and enabling a developer to commit the code, to push the code and walk away with the URL, is sorely missed in the Kubernetes world. And that is what I call my developer experience.
So why, I mean, these seem like why are these tools missing? I mean, it's not like this stuff is new at this point.
So one observation that I made is Kubernetes has grown dramatically in the last 5-6 years. This technology is only 5 years old or 6 years old. Kubernetes was announced as an open source project in 2014. It got submitted to CNCF. It became more broad only in 2015. So it's a very young technology. And the industry and the ecosystem, the community has spent time tightening the screws and the nuts and bolts from the ground up to the top layer. For example, today, container D, which is the lowest common denominator of Kubernetes, is highly mature, highly evolved, highly secure. And if you look at service mesh, if you look at the container native networking interfaces, all of them have stabilized and all of them have become very mature. Now, very little focus and effort has been put on developer experience. The industry and the community has been busy working and strengthening the infrastructure layers of Kubernetes and paid little attention to the developer experience layer.
I see. Okay. So when I say it's not like this stuff is new, it's still new enough to where some of these tools have not emerged yet, is what you're saying. So developers are famous for, if they don't have the tool, they go out and they build it. So, I mean, you're saying this, experience here is broken, but I mean, a lot of people must already actually agree with you. So are they working around it? Are they building these things in now?
So there are very interesting dynamics in this space. So you have been with Sun, you have been with Oracle, you know what I'm talking about. I've been with Microsoft, and there was a point in time where we competed, and I was positioning Microsoft and Visual Studio against Eclipse and J2EE IDs. So we come from the same background.
Yeah.
Now,
I remember the Eclipse NetBeans fun. I remember.
Exactly. Now, remember, the platform experience has to come from proven platform vendors, like Microsoft, like Oracle, like IBM. But why aren't they doing anything about it? Well, the dynamics are extremely different from what it was 2 decades ago. Today, if you look at Oracle's Kubernetes engine, Microsoft AKS, Amazon EKS, Google's GKE, all of them are running on the same open source software. So the differentiating factor between one vendor and the other is almost nil. I get the same Kubernetes API, I get the same tool chain, irrespective of what Kubernetes I'm targeting. In fact, you can hide this completely from the developer, right? I mean, if I switch my context from Oracle Kubernetes engine to GKE, I don't even realize Kubernetes just works the way it is. Now, with that becoming the lowest common denominator, developer experience is becoming the differentiating factor for each of the platform vendors. And that is becoming their secret sauce rather than an open source project. For example, Google has built something called Cloud Run. So Cloud Run is a platform as a service layer technically on top of Kubernetes. And it's a wonderful experience, and that delivers exactly the same what I mentioned. You bring the source code, you walk away with URL. But is Cloud Run open source? Can I deploy it in my on-prem Kubernetes cluster? No, that is Google's secret sauce. Google wants to deliver it exclusively for customers using their cloud. Same thing with Amazon. Amazon has built something called App Runner. Same promise, bring the source code, walk away with the URL. Is App Runner open source? Can I run it in any Kubernetes cluster? No. Now let's look at Microsoft. They built something called, more recently, the container apps, Azure container apps. Same promise, bring the source code, walk away with a URL. Is container apps open source? No. Microsoft wants to enhance it. They want that to be a differentiating factor to attract developers, and it runs exclusively on Azure. You see where it is going. So developer experience is becoming the differentiating factor and the secret sauce rather than an open source layer.
Interesting. So I haven't been following this trend. I mean, I've been so focused on open source as the experience in terms of people being able to contribute, taking the code and changing it, contributing it back, and being a part of the community. So is this a global trend, or is it mostly in India, or so do you see sort of a differentiation in terms of where this is emerging physically in terms of
It's a global trend. No, this is a global trend. So if someone is innovating on developer experience, they want to monetize it. There is nothing wrong in it. But what is glaringly visible as a gap in the stack is the lack of the developer experience layer. And I'm actually surprised that till date, no one has built an open source portable application layer that can run on a Minikube to a multi-node cluster in the public cloud. And that is actually an opportunity for a lot of platform companies, who is really looking at contributing and making a mark in the cloud native world.
So talk a little bit about the complexity of doing that, because if you see this as just an obvious opportunity, then why aren't people jumping at it to build that very
right. I think I have spent a lot of time analyzing this, thinking over it, and participating in a variety of debates and discussions. This is not the first time I have been on multiple panels where I've been very vocal about this. So one reason why this is not plagued, this gap is not plagued, is there is no prescriptive standard, an acceptable prescriptive standard for this. For example, to deliver this, remember, on one side of the spectrum we have source code. On the other side of the spectrum we have the URL or an endpoint. Now, in between, what happens is an orchestration of multiple tools. For example, when you commit, you need to have an internal Git repo. Once the code is committed, then you need to have a CI system, something like Jenkins that most of us are familiar with. Then there is a build system. Then there is a release system. And then there is an image registry. And from there to the deployment. So this is actually assembling a set of open source components and agreeing upon the standard workflow on how all these tools are stitched together. Now, there are two issues. One, no one is able to agree upon the standard tool chain. For example, there are tools like Tekton, Kaneko, and then of course the Docker, CLI. So there are like a lot of competing alternative open source technologies. No one is able to agree upon number one. Number two, there is no standard spec on how to do this. There are specs for everything in the cloud native stack. For example, there is a container runtime interface that tells how Kubernetes will talk to the underlying resource. That's the reason why people could build a VM orchestrator for Kubernetes. It doesn't matter how Kubernetes orchestrates the resource. As long as you expose your resource to a CRI, the container runtime interface, Kubernetes can do it. And same thing with service mesh interface, with container storage interface. For everything, there is a well-documented spec, and vendors take that spec and implement. Guess what? There is no application spec, application platform spec. And that's where the gap is. So first thing, to summarize, extreme fragmentation of toolkits. Second, a lack of agreed upon spec to translate these tools into an implementation.
Okay, well, so with a lack of a specification, so that really is going to sort of, presumably there would be multiple ways of doing it then, and a lot of conflict around that, or at least conversations about that. There's a lot there to take place in 2022. Do you think that this problem will be addressed in the next year or so, or is it a multiple year program, or is it a multiple year issue?
It's a multi-year issue. We may not be able to find like a very short-term solution in the next year or so, but I'm hoping with the dust settling down and with Kubernetes becoming boring, at least 2022 will see the process of standardizing the application platform, someone creating a spec, and the momentum picking up.
Cool. Interesting. Okay. Well, let's wrap it up there for this year. 2021 is over almost, thankfully. Is there anything that we've left out? Is there anything that we haven't covered here for this conversation?
There are a few, but I think in the given context and the time that we have, we covered the most important aspects.
Okay, cool. All right, Johnny. Well, have a fantastic new year. And I'll be looking forward to sometime soon, I'm not even going to say when, getting down to Hyderabad and actually meeting live for a little bit of tea. Sound good?
Absolutely. I'll get you an Irani chai, which is very famous in Hyderabad. Looking forward to it.
Very good. Talk to you soon, my friend.
Thank you. Thanks, Jim.
Bye-bye.